Now, how can we use proportion to find out side lengths? Here's an example. The proportion of BC to AB is 1 to 2, and we are supposed to find AC. So let's write down our proportion. BC over AB is equal to 1 over 2. Now let's go and fill in everything we have. We know that the length BC is 4 over x plus 4, which is AB, is equal to 1/2. And we're going to go ahead and cross multiply. 4 times 2 is 8, is equal to 1 times x plus 4. And I just put these parentheses here out of habit, so we never forget to do that. Obviously, if we're multiplying by 1, we don't really need them. So 8 is equal to x plus 4. Let's subtract 4 from both sides. And 4 is equal to x. Now, don't stop here. Let's look back at what we were actually supposed to find. We were supposed to find AC. And AC, as stated here, is equal to 2x. So, if AC is equal to 2x, then AC is equal to 2 times 4. And that means AC is equal to 8. Here's another typical example of where we can make mistakes if we don't go all the way to the end and don't read our instructions carefully. Here's example 5. Triangle ABC is similar to triangle EDC, and we are supposed to find DC. Now let's see, DC is corresponding to BC. So DC over BC is equal to, here are sides that we have values for, and BC is indeed corresponding to AC. That's why this works, and therefore we can use them for our proportion, EC over AC. Okay, then let's go and fill in what we have. DC is x. We don't know DC. We were supposed to find DC. And that is over BC. And, let's see. We don't have BC. However, we do have a piece of information that can help us out. We know that all the way from B to D is 10 units. And BC is those 10 units minus the part that's already been used up for CD or DC, and that's x. So in other words, BC has to be 10 minus x. Lucky us. And now EC we do have. EC is 4 over AC, which is 8. Alright, and now we can go ahead and solve this. 8x cross multiplying here is equal to 4 times 10 minus x. Distributing our 4, we get 8x is equal to 40 minus 4x. Now we're going to add 4x to both sides. We get 12x is equal to 40. Divide by 12 on both sides. X is equal to 40 over 12, and 40 over 12 we can simplify, dividing numerator and denominator by 4, we get 10 over 3. And wait a minute, we're supposed to find DC. DC happens to be the same as x, so DC is also 10 over 3, and this is our final answer. In our next example, we are given the similarity statement, polygon or quadrilateral to be exact, ABCD is similar to WXYZ, and we are supposed to write a statement of proportionality. When we do that, we take a similarity statement and we go from left to right. So AB is corresponding to WX, and that has to be equal to BC over XY, which has to be corresponding to CD over YZ, and then last but not least we got AD, which is corresponding to WZ. In part B of the problem, we're supposed to find the scale factor. So in order to do that, we need to plug in all the numbers that we have and see what we can do. From our left quadrilateral, we have the length of AD is 14. That's all we have here. But let's move to the other one. We know that WX is 8, XY is 4, and YZ is 3, and then WZ is 10. So luckily we have one ratio that's complete, and that one we can use to find our scale factor. 14 over 10, which can be simplified to 7 over 5, or if you like, 7 to 5. Okay, next we need to find the values of the missing side lengths. In order to do that, we need our scale factor. A, B, and we know that WX is 8, so AB over 8 has to be the same as 7 over 5. BC over 4 has to be the same as 7 over 5. And CD over 3 has to also be equal to 7 over 5. Then let's go ahead and do our proportions. 5AB is equal to 56. 5BC is equal to 28. And 5CD is equal to 21. Dividing by 5 and using our superior division skills, we get that AB is equal to 11.2, BC is equal to 5.6, and CD is equal to 4.2. Next, we're supposed to determine the perimeter of each figure. Remember, perimeter is the measure around a figure. Going all the way around. So, what is the perimeter of ABCD? We have AB, which is 11.2, plus BC, 5.6, plus CD, 4.2, plus, let's not forget, AD, which we already had, which is 14. Adding the four sides together, we get 35. Let's find the perimeter of WXYZ. And that one is 8 plus 4 plus 3 plus 10, and we get a total of 25. In the last part of this example, we are supposed to say what is special about the perimeters of similar polygons, and to do that, let's look at the polygons we have here. We have a perimeter of 35, for our larger one and 25 of our smaller one. And let's make that a ratio, 35 over 25. And what do we see? When we take that ratio and we simplify it, we get 7 over 5. Aha! So the ratio of the perimeters of the two polygons is the same as the scale factor, and that's always the case. On to our last example. Are these polygons similar? Yes or no is the question. If so, then do the following. Explain why they are similar, write a similarity statement, and determine the scale factor. So in order to determine if they're similar, we need to determine, are all the angles congruent? And let's look at the angle congruence marks. We have one pair of angles that's congruent right here, and another pair of angles that's congruent. We don't know anything about the last pair of angles yet, or do we? But let's remember our third angles theorem. If two angles of a triangle are congruent to two angles of another triangle, then the third pair of angles also has to be congruent. So we can answer this question, are the angles all congruent? Yes, they are. The other question we need to answer is, are the sides all proportional? And in order to do that, we need to relate the corresponding sides. If we want to start with the largest side, we get 12 over 9. And that, if we simplify it, is 4 over 3. Let's look at the next largest side, 8 and 6. 8 over 6 can be simplified to 4 over 3. And now we go to the smallest sides, 6 over 4.5. And that can also be simplified to 4 over 3. So the answer is yes, all sides are also proportional. This means these two triangles are similar, and we can write our similarity statement. Now for our similarity statement, just like for our congruence statement, we have to make sure that we follow the same order. If we want to start with the first one alphabetically, L, M, N. So triangle L, M, N is similar to, and see how we went from the angle with the 2 congruence marks to the one with the 1 congruence mark to the one with 3 congruence marks. In other words, we went from T to P to O for the other triangle. And here is our similarity statement. Last but not least, we are supposed to determine the scale factor, and we are in luck. We already have done that before, right? Our ratio, which kept reappearing when we put the corresponding sides together, is our scale factor, and the answer is that's 4 over 3. Alright, for your summary, I would like you to write down some thoughts about where outside of a classroom can you see similar figures. Okay, that's it for today, and I will see you in class.